Uh,
Hey, looks like we're
Yeah, right.
live. So, greetings, fellow nerds. Welcome to another episode of Between Two Nerds, where we talk with prominent guests about all aspects of the networking industry, from
so what
protocols old and new to industry trends and drivers. Russ,
you said prominent. I'm not
prominent.
there. So no. So you
You're
need no.
you're the prominent Russ White. And so
You're right.
I'm not even gonna finish my intro blurb here because you made it better. So
Prominent.
yeah, that's
Prominent
right.
is something.
Look at that. You're
In-
even
Now you have
between
to
the
feel
two
Jeff,
nerds.
he can make a wish.
So yeah. So Russ and I were chatting at AutoCon a couple of weeks ago in Austin. We never actually saw each other there. That's a comment on how good AutoCon is becoming. Is that you can have friends there and never see them. It's gotten so big, but I was thinking, man, we got to have Russ back on the show just because it's so much fun for the three of us to chat together and just old friends and all of that. And pretty much said, I don't really care what the topic is. It's more about having Russ on. So Russ, you actually came up with sort of a key for all of this. I have no idea where we're going to go with this show, but you said that someone had asked you an interesting question at AutoCon, and from there it just sort of okay. Well, here's an idea for a show. So
Yeah.
you want to tell us about that?
Yeah. So somebody walked up to me at AutoCon, and I am rarely ever asked questions like this. A very perceptive, very interesting question. What is the difference between a tunnel and an overlay? So most people ask, when is something a tunnel and when isn't it? Like, why is Ethernet not a tunnel? Okay, well, we have an answer for that, right? There are answers for this type of question. But I don't know. What is the difference between a tunnel and an overlay? I have a definition. And then so that leads into the whole topic of SRv6, which is I think where Jeff T wants to go is SRv6.
Not necessarily.
No, please don't take me down that road.
Oh, come on. You love
Yeah,
SRv6.
no, that's
Hit it.
you what? You hate it?
No, it. The rod.
Oh,
Oh my goodness. SR in general. Okay, we can talk about SR and PLS just for you, Jeff.
there you go. Yeah, I have to say, segment routing is something I understand on paper and all of that. I've never worked with it. Yeah, I always think of it as a service provider technology. Is that a fair assumption? I mean, I know
I
that I actually looked it up. We talked about. I think the title of this show was SR in the data center, and I looked it up, and it said, yeah, people are using it in the data center.
Yeah. So MPLS or MPLS as such, it's not technology you often see in data centers, right? For a variety of reasons. There was actually deployment in what was the name of the company out of Russia, Yandex. They actually did full MPLS implementation to the host.
Yep. Now, okay, so let's begin with the question I ask, and then let's move into. Okay, so my answer to that question, I just want to hear your answers before we move into SR more specifically, is that tunnels emulate circuits, and you can create an overlay using tunnels.
Mm-hmm.
Okay, just like you could create a full mesh of. Oh my goodness, I'm going to show my age. Frame relay tunnels, right? Or circuits or whatever you want to call them, or T1s. You can make a full mesh of the things. Have at. We used to have one on McGuire Air Force Base when I worked there. We had a full mesh of T1s and DS3s. Like, yeah, you can do this kind of a thing. But it's actually hard to build a full mesh of tunnels. You can automate it, throw it in BGP, throw all this other stuff. But I think the difference to me is that an overlay, a true overlay, doesn't emulate an overlay protocol does not emulate a circuit. It emulates a topology.
Yeah.
And so I don't care about your source address in my topology. Just like if I receive an IP packet as a host, what do I do with the IP, the source address field? Nothing. I don't care.
RPF?
Yeah, well, RPF, but that's on the forwarding side, right? But yeah, you're right. But I mean, other than that, I don't really like look at the packet and go, oh no, this is from host 99. I need to treat that differently than I would a packet from host 98. It's packet. I received it. It's to my IP address. Thank you.
So
I'll process it.
there's something to it, right? And I, going back, I think the best analogy to tunnel network is physical tunnel. You enter in, you can only exit at the end of the tunnel. There's nothing in between you could escape it, right? So I think
Yeah.
physical tunnel is the best analogy for virtual one. To the source, especially looking kind of AI data centers, which is the hot thing today, we would like to get notification about something bad happening in the middle as soon as possible. Traditionally, you would go all the way to the receiver, think about ETN marking, receiver will process, turn around, and send CNP. So if you are within, 10 microseconds within data center, it's reasonable. What if you need to traverse one? What if you are in the metro? So suddenly your RTT is in milliseconds, and by the time you receive information back, it might be completely irrelevant. This is where technologies such as back to sender, which has been discussed in IEEE for a long time, now it's kind of making it into UEC, some other type of consortium. You need to be able to send packet back to the sender at the moment it's actually dropped. Yeah, so potentially you can trim it and send back, potentially you can send something else, but practically you need to know how to get back. And this is where source route becomes interesting.
Yeah. Yeah. Exactly. Yeah. So the people in the middle care about the source address, but not the person who receives the packet necessarily, which is why I say it's like a virtual topology. It's just like IP, but it's IP on top of other stuff, basically. So that to me is the difference. So now we talk about SR. And what interesting to me about SR is, Jeff, you're like Jeff D. I guess I should say D and T or something. I don't know. Anyway, left nerd, right nerd, or
There you go. Yeah.
something.
Let's go.
Is it left from your perspective or is it left from the viewer's
No,
perspective?
you have to guess. You have to guess. So, is that SR is an overlay only protocol? You're talking about MPLS is also an overlay only protocol, and it's really designed based on ATM switching. That's where it came from.
Yeah.
And so it's this really cool idea. I remember when Yakov was coming up with this and working on it when he did tag switching, that I can build to a lot more scale if I carry a lot less state. And so I'm going to strictly take the state out, and I just don't care. And the state I take out is if I'm the receiver, if I'm the tail end of the tunnel, I don't care who the head end is. That's just state I can just get rid of in my switching path and everything else. I just don't care. So yeah, so all of this comes down to SR to me is like a second generation of straight MPLS. And MPLS has a lot of complexity in the label swapping that makes it very difficult to deploy. Which, by the way, going back to Jeff T's original comment about data centers, a lot of people that I worked with wouldn't deploy MPLS in the data center because it costs more. You pay for it.
Mm-hmm.
I would say that might be true for reasonably old silicon as of today. And I would also like to dismiss kind of myth that routing is more expensive than bridging. Modern silicon does all three at exactly the same.
No, I don't mean that. I don't mean that. I mean vendors literally charged to turn on MPLS.
You're looking against 7, maybe 10 years back. Today,
yes,
that's
7, right. But that's what set that's like, people went to IS in service providers because at that time that implementation was quote unquote better than the OSPF implementation that was available at that time. Does that make it valid today? I don't know, but that's the history of how we got there. And so the same thing I think with MPLS is that people wouldn't deploy MPLS because you went to Cisco or Juniper and they said that'll be an extra $10,000 per switch. And when I'm deploying 500 switches, oh wait, no, yeah. I'm not paying for that. So I think that got people out of the mental space of deploying MPLS in data centers.
And
Um,
I think that's an interesting point to that normally LT VPNs, right?
yes,
LT VPN has very specific statements that next hop must be labeled,
that's right.
non-directly connected, right? That's why we've seen the weird stuff like MPLS over UDP, like Contrailish, right?
Yeah,
Practically, this is why EVPN eventually took off because it's just L3 VPN over IP.
yep,
Yeah, and
Right?
which
Exactly
is
same thing.
interesting because I mean, L3 VPNs, L2 VPNs, EVPN, all of that is all MPLS heritage.
yeah,
But it allows NextHop to be IP, non-labeled. And that's what
correct.
made all the difference for data centers.
Yeah,
Yeah, exactly. And there's not just the labeling in the sense of, oh, this is a different kind of address. It's the ability to troubleshoot. It's the ability to track things back. And by the way, this is the thing that I think was the hardest for me to deal with in true MPLS where I'm label swapping is if I'm sitting at a tunnel tail end at a penultimate where I'm going to pull the outer and just have the inner, and boom, I'm going to actually route it based on the routing header, and I get 1 out of 4 packets are blown up. Okay, where is that happening? How do I trace that back? I've got to go back and look at every label swap all the way through and understand what that path looks like. That is not easy to troubleshoot to me. Like, that's hard.
So
absolutely.
that's exactly kind of the trade-offs. On one side, we made the swap local to the device, right?
Right.
Which
Correct.
significantly reduces complexity and scale because it's
Mhm.
local. You only need to understand your own context, not someone else's. On
Yep.
another side, because it's distributed, suddenly you don't have end-to-end view and you need to go kind of hop-by-hop troubleshooting. It's a classical dilemma.
Yeah, it is. Yeah. I mean, it's all the iron triads, right?
Yeah.
Speed, quality, or cost. Pick two. That's
Give me the
exactly what
money.
it is. Yeah. So yeah. So I don't know. So SR is interesting because it doesn't do the label swapping. I think that's the number one. The two things that are interesting are you can do IP.
I disagree with you. Not most, some implementations, the beginning did swap same by same.
Yeah, that's true. That's correct.
Exactly same action, just the value of the label stays the same.
Yes, exactly. Yeah. But that's because that's the way the hardware was built, right?
Yeah.
Right. So yeah. So I don't know. I mean, but you have an end-to-end global identifier, which makes the operations people a lot happier, honestly. And then you have that you can do it with IP. And IP is extremely interesting compared to deploying a secondary thing, whatever it is. And Jeff D, one thing that's interesting about spine and leaf topologies in particular is that I can describe the entire path on the coming from the workload to the top of fabric.
Yeah.
Right? If I say I need the traffic to pass through this particular top of fabric device, this router, I may have 20 paths to get there. So I might have to say, okay, I need it to pass through this spine box and that top of fabric. When it reaches the top of fabric, there's only one way from that top of fabric to every destination in the entire fabric. So in a 3-stage, in a CLO, I can describe the entire path with one label. In a 5-stage, I can, in a butterfly or a 7-stage, I have to add one more label for every path, for every hop than a stage I'm adding. But a lot of times I don't care. All I care about is which fabric, which plane I go through, which I can solve with a multicast or an anycast label in the top of fabric. So all of a sudden, my entire traffic engineering problem becomes 1 or 2 labels, or traffic steering, I should say.
If you decide to do traffic engineering data center, which is kind of much bigger decision than
right.
Yeah.
Yeah. I should say traffic steering, not traffic engineering, because that's a different entire problem. But that's why it's interesting. That's why it becomes interesting for a data center fabric. There's a very little overhead in terms of state but I get an awful lot of direction out of that little bitty bit of additional state, and it's all IP.
So I would like
That's
kind of to change the angle on the same problem, and especially given that I spent most of my time last year kind of outside the BGP on a Service 6 problem.
my condolences.
I can speak to that. That's actually IETF draft that describes the deployment. I'm not sure. They actually did put the Microsoft name in it. So it's a potentially how you deploy the services in data centers to do particular things. Right? So
is that in the Spring working group?
No, I believe it's in segment Service 6 Ops.
Oh, okay.
Spring. Sorry. Keep going.
Yeah,
You have to say that whenever you talk about the working group.
That's right.
It's reasonably easy to kind of deploy Service 6 in data center because of its kind of very, very standard way of interconnecting, right? Mm-hmm. You know when you go up, you know when you go down and this kind of stuff. So it's pretty easy. The interesting point is how you use it, right? Again, we're talking about something with RTT of 10 microseconds.
Yeah.
Most. So the paradigm of source-based routing is that source decides where to send the traffic, the path it's going to take. So you need to have a feedback loop that is fast enough to come back to you before you send next packet, which is at 400 gig, you can do the math.
Yeah, exactly.
Right? So how do you monitor viability of a path? Because now we are talking path, not next hop, but you are taking entire path and you program it in such way that you can program it at the sender and fast enough to still be relevant. So if it's congestion or something goes on, you would like to choose another path. That's number one. It's non-trivial, and it's really non-trivial, but your feedback loop becomes that short, and eventually, if you don't react in time, you better not react at all. Right. Number two, we are talking about potentially something with hundreds of thousands endpoints. So you need to build a controller that is capable of taking this hundreds of thousands endpoints with number of links that is in tens of millions and making sense of it. So you need to build full graph. You need to overlay this full graph with potentially different classes of services, with potentially different behaviors. Well, it looks really, really simple on a switch. You have 128 uplinks. Each one gets a label, you are done. But when do you change it? How do you change it? When you go back, what if switch went down? What if link went down? What do you do with it? All of this is absolutely non-trivial, and building such controller infrastructure, I believe there are probably 2-3 companies in the world that are actually capable of.
Yeah, a lot of people don't realize that scale itself has its own quality problem, or its own quantity is a problem separate from, like,
there's also non-obvious relationship between centralization and decentralization, because what if switch went down and suddenly 20,000 servers decided to switch to another path? What if all of them switch to the same path?
Yeah.
You're in much worse situation than you were before. So somehow you need to realize that different servers that are taking really distributed decisions need to take different paths in case of failure, right? So all of this is really, really complicated.
Yeah. This is the dynamic incast problem, basically. Yeah.
Yeah. You've been talking a lot about, you were talking about controllers, and what it conjures up in my mind is the old definition of SDN, which was, you have a separate controller that is managing the network. And, with things like, Jeff, you and I, for so many shows talk about EVPN and all that kind of stuff. That's still MPLS heritage, because you're pushing the intelligence to the edge and out of the core. The core is just pretty much dumb switches, but moving it to the edge means you're putting the intelligence in the leaf switches. And the sort of the old concept of SDN is you're pulling the intelligence out of the leaf switches too, and you're having a controller dictate the entire abstract topology. Is that
for non-RDMA workloads of kind of service provider classical networks? Propagation of change in reachability through BGP is good enough, right? Yeah. You can put in BGP doing hundreds of milliseconds with no problems today. Now, when you are sending when you're doing actual training, 100 milliseconds is a eternity, right? So suddenly BGP as a propagation medium doesn't work. You need something that's really fast. And again, scale. If you do it centrally, you cannot get the speed. If you do it distributed, you don't get the correlation.
Yeah.
So the trade-offs are non-trivial.
Yeah. Yeah, and I also think the difference is too with SDN. The original SDN vision was, okay, we are going to replace the entire control plane. This doesn't
Yeah.
do that. This
Yeah.
this basically we are saying, just like you have an underlay, which has all of your infrastructure routes, your tunnel tails and heads, and then you have an overlay that has workload routes or customer or whatever you want to call it in the traditional ISP sense of doing things. Now you have this controller overlay that knows about quality, and all it does is tweak the overlay and the underlay topology to get things where they need to be. So the state is actually divided into three pieces. My state's divided into physical infrastructure, workload reachability, and VPNs and VRFs and all that stuff, and segmentation. And then I have this third layer now that's like, these are the exceptions. That's the way that I kind of look at it. I don't know, Jeff T, that may be, is that what you would say, or is that kind of crazy?
So again, requires some innovation and thinking, because normally routing protocols tell us what they know, not what they don't know.
Yeah.
So you need to invert the logic.
Yep. This is actually, by the way, one of the problems with routing protocol security in general that people don't think about is there are no negative advertisements. I cannot.
I just published a draft 3 weeks ago that proposes new SAFI in BGP that does that.
Oh, please. Oh my gosh. Because that is a major issue, right? There is, as far as security goes. Now, from a regular routing protocols operation thing, it's like nobody really cares about negative routes. Implicit withdrawals are just happy and everything else. But if you're going to say you're going to secure something, then you need to know when it's gone away in a secure way. You can't just say, oh, I don't see it anymore, therefore it's gone. No, that's not the way security works.
Isn't that what? Isn't that what a BGP? Oh, I was just going to say, isn't that what a BGP withdraw does, though? Isn't that?
No. BGP withdraw has very specific logic. It can only withdraw something it has advertised before.
Exactly.
Oh, okay. Now,
and you have
when you're saying negative route, you're saying don't use this route.
Yes, or even eliminate.
I was very specific in the draft. I use BGP as metadata distribution channel. There is a special RIP I call UI RIP or unreachability RIP that allows you to propagate this information across the network. It doesn't touch the RIP, the FIP, or any of infrastructure, right? Actually, looking again at Rift, that's where idea is coming from, pretty much.
Oh, interesting. Okay.
But I published a draft a couple of weeks ago, and take a look.
Yeah, I wasn't aware of that one. I'm going to look right after this show.
And it's pretty cool. Imagine you drop a route for, I don't know, RPKI files. No one would know that you dropped it. But now you, as point of observation, you have to state route was there and then disappeared, which triggers advertisement of an unreachability route. And you as the observer can do something with it, which is really up to you what you do.
So going back to SR, so again, I've said what I think is interesting about it. Is there more to it than that, Jeff T, that you know of, that you've thought of, that is, because again, to me, the interesting thing is it's IPv6. And you can do service chaining with microsids, which frankly, I find a little frightening, but okay, we can go there, right? That's okay. I don't know. I worked at a place once where we did poor man's SR.
Let's clarify a point. People often say that SRv6 is IPv6. It's an overlay. RFC 8200 explicitly did not allowing you to mess with IPv6 in transit.
Right.
You must impose additional headers. So practically it's V6 and V6 encapsulation, always. You cannot do it otherwise. You violate 80 to 100, you are out of the room.
Yep.
So it's classical underlay, overlay. You have two different encapsulations, happen to be the same, but two different encapsulations that do different things.
Yeah.
Right.
Because the overlay, the SRv6 IP address, which looks like a v6 address and shares the same space, is technically a service endpoint
Yeah.
in the network. It is not a topological location. So a v6 address is a topological location. An IP address is a topological. And I use that word very carefully because people in their heads associate topological location with geographic location, and these are completely different things. And so it may be that this IP address is next to that IP address, but it might not be. So really what the network cares about is, where is this destination, this reachable destination, connected to the network topology, not physically, topologically. So you actually, like Jeff says, you're going up one more layer. You're not talking about topological locations where it's attached to the network. You're talking about a service. What does this service do? And so that's a very hard thing for people to get their heads around, because the two are used interchangeably. It's a service, but it's a service with a topological location.
I think another interesting thing is that traditionally, in at least provider networks, we've been carrying the data plane identity separately from what to do with the topology. So any MPLS network is a good example. You carry a label, but the context of the label distributed by LDP, SR, BGP, whatever, favorite protocols, right? Here we carry SRH as part of data plane, which, I mean, besides the kind of size of the headers and everything else, it's not very healthy separation of concerns. It works, but at price, right? Again, the header size, especially for smaller packets, is prohibitively large, and it requires local configuration to actually make sense out of it, right? So you need to define behavior, flavors, and all this beautiful stuff in the services. So again, something to think about in terms of complexity, and it's more theoretical kind of thinking because it really does work, but at price and again, trade-offs. On another side, you've got the compressed thing, which is interesting because it doesn't carry SRH anymore. But again, the definition of behavior needs to be there, and the complexity of configuration, cost of failure are significant. So yeah, they're all great technologies, and done in right place and right way brings really amazing results. But if you don't do it right, you're just shooting yourself in any possible part of your body.
Yeah. Well, and this is part of the trade-off, right? Is you need to be very careful about, like, for instance, your addressing. Okay, you had to be careful about v6 addressing before. This is another level of complexity in addressing. That is, like, can you aggregate it? Where would you aggregate these services? What's going to happen if a particular service goes? I've heard people say things like, well, we can just allocate a v6 prefix per region, and we can stick services within that prefix, and we know it'll be within that region. And I'm like, no, it actually doesn't. It actually doesn't work that way. I'm sorry, but it doesn't work that way. Because the service, you have to know, if, like, for instance, if I'm looking for a DNS service, I can't just send the DNS packet to every region and hope that there's a DNS prefix within that region. Like, I've got to know which regions have that service. So aggregation becomes extremely weird to think about and try to understand.
Power of leaky abstractions.
Yes. Oh, yes. Yep.
So again, I think it's kind of main point of our meeting is to let our listeners to understand that, a lot of people listen to some other vendors and get brainwashed, and we go this way. That's going to save world's hunger and everything. There's always price to pay, and even if your data plane looks simple, usually there's complexity in control plane, another way around. You remove your control plane and make it very simple, and you shove everything into data plane. Suddenly your headers are larger than your payloads. So
yeah.
Yeah. So I don't know.
Does I get what you're saying about headers being larger than the payloads, but with modern silicon, does that matter?
It matters efficiency on the wire. The more space you take by header, the less amount of payload you can attach to it.
Yeah.
And eventually, you build network for sake of network, right?
Yeah.
Mhm.
So Eric Osborne actually did this funny thing when I was in TAC, where Cisco TAC, where he built he took a Cisco 7200 and he actually an old 7200, not one of the new ones, and he built a series of virtual interfaces, and he got to the point where he could actually cause the IP packet to fragment if you put more than like 48 octets in it, because he had so many tunnel headers stuffed on the packet that the tunnel headers were consuming like 1500 octets almost just in tunnel header. Like, wow. Well, I remember way back in the day, we cared about how chatty a protocol was. I wrote white papers on vines versus netware, and which
Yeah.
one was, which one's more chatty, which one consumes more. Oh, and then there's IP. Oh, that's even worse. Like whatever. And then we got to this point where we had all these big links and nobody cared. Well, now we're worried about delay and jitter. And guess what? It matters.
Yeah, and that was the root of my question was, I mean, obviously, when bandwidth is at a premium, when processing is at a premium, all of that matters. But if you look at modern data centers where you're running 400 or 800 gig or something like that, and these massive processors, by NVIDIA or Broadcom, any of those that that's where it's like you've got all these rich resources. It's kind of the same thing with IPv6 as far as addressing resources. You've got all this rich resource. So does that kind of conservation even matter anymore?
So I think actually now it's a bit different, right? We had steady evolution of speeds in kind of on 3 years cadence. You would get 10 gig, 25, 50, 100, so forth. Now all of this need to be aligned with the speed of, GPU 3. If your GPU doubles, the speed your network needs to double. There's no other way. So practically, we are moving kind of to 18 months cadence, doubling the speed. And it was very easy to go from 48 to 32 nanometers. Now we are going from 3 to 2 to 1, which is by far most complex problem in kind of building silicon, right? So the only way to make it faster is to reduce surface and functionality.
Yeah.
Your main functionality is speed. It's not anymore deep lookups or any of this intelligent stuff, right? Mm-hmm. You need to take packets from left, send it to right, and do it at, I don't know, terasecond. So we actually having less and less capacity to do something intelligent with the packet. We are busy 100% just taking it from left to right and doing this in time. So this ability to do something intelligent is disappearing.
This is actually an interesting conversation I had with Lynn, co-founder of Cisco. Lynn, what's his last name? Boz. Anyway, co-founder of Cisco. Yeah. Lynn. He was actually at AutoCon.
Really?
Oh. Yeah. And I saw him wandering around in the show floor. He's working with some company now, founded a company or whatever, doing optics. And so we got into this long conversation about optics, because this is another problem you're talking about, right, Jeff? Is like co-packaged optics or on switch on silicon optics. Wow. And I mean, is that actually going to work? Is that a long-term solution? Can you make at certain die sizes? How many optics thing can you stick on a single die size? And like, there's all these weird problems in the heating and everything else. And Lynn was talking about his biggest issue with it is power. He's like, how much power can I get out of that silicon photonic array to actually drive more than a foot or two? Like, how far is this optical cable going to be able to go? And when I start throwing things into racks and I want to run a 20-foot optics fiber to run to the top of rack switches or whatever off of that server, because I have 5,000 ports in a single rack or whatever it is. Like, what does that look like? How does all that work? And so that's another interesting thing we're talking about here, right, Jeff? Jeff,
Sure,
with the
certainly.
trade-offs.
Ultimately, how do you make this field replaceable?
Yeah, and how do you make this field replaceable? And even what it does to the wiring, right? Because now the wiring is not going to a connector in the face plate. It's going through a hole in the face plate to the chip.
Yeah.
Oh, well, now wait a minute. How is that going to work?
But I would think we mostly kind of solve the problem. At least my products are all coming with CPO next year, right? And we also managed to build field replaceable units that are actually field replaceable. So you don't need to throw away switch, you replace one of these units. If you look at reliability, I think it's about 10 times better than reliability of pluggable optics. So I think this is the kind of obvious next step in the industry because of lower power consumption, high reliability, and just because everybody wants it.
Yeah. Yeah. And everybody wants it because it's probably, I would guess, lower heat and higher reliability.
Yeah.
That's my guess. Is the heat. The heat's one of the big issues. Like, I'm not going from electronics to optics in quite the same way, which makes it a little bit cooler. So I don't know. But these are all the interesting trade-offs. See, we started out in SR and we ended up in optics. I'm not sure how that happened, but okay.
But so going back to Service 6, probably things to think about. Probably you don't want a acceleration data center. There's cost, there's size, and the diameter of data center should really allow you to use acceleration-less technologies. So if you kind of read in literature, it's coming from service provider. Also, normally the common format would be F3216, meaning your service block is 32-bit and then each seed is 16. Don't do this data center, makes no sense because now you're looking at a much larger fan out. Use F1616, gives you one more compressive, so you're down to 7. 7 is a respectable site. With 6, you can actually, in large deployments, run out, right?
Yeah. So I've actually deployed poor man's SRv6, as I would call it, or poor man's traffic steering, by just saying, making the observation that every one of the hosts I have deployed in my data center fabric, all the workloads get /64s. There is absolutely no reason that I can't say every video application sitting on this host gets a different /64 than the rest of the host does. And then I can turn around and I can take that information and shove it into routing and pull all of those destination addresses across a single plane. And now I have, yeah, sorry, Jeff, go ahead.
There was presentation from your former employer on exactly this technology. I think it was, I think, probably Facebook networking scale. So you can actually identify video segments kind of as part of this, as part of IPv6 address. Really, really cool stuff.
Yeah, yeah. And you don't even need the SRH. You just need its additional state. Oh, well, I mean, that's the trade-off. Sorry, you got to trade off someplace. So deal with your additional state. That's what it's going to be. And, it allows you to do a lot of the same things without the deep complexity of running a true overlay per se. Yeah. So it's an intermediate step that you should look at if you're in thinking I need traffic steering, but I don't need all the other stuff. I don't need service chaining. I don't need all that other stuff. I just need traffic steering. Okay. Well, there are ways to do that.
Yeah, I think it kind of has been a theme that myself and Jeff have been pushing through all our meetings. Don't jump on latest stuff just because it's there. There's always price to it.
Yeah.
Either complexity, sometimes it's just the cost, sometimes it's just tool replacement, but practically think what you need, not what you could do. And just because something is there, it doesn't mean you have to. Just
although be careful, but be careful about what you might need 5 years from now too, right? But again, I'll say using a poor man's V6 traffic steering it would be very, very easy to convert that to full on SRv6 in 5 years. So, like, it's cool to build IS to IS with TLVs and BGP instead of the way OSPF did it, which was fixed link fields by and large. That's cool. And there's a trade off there in chattiness and everything else. But I think it's more important just to realize that your requirements could change. Fine. Set things up so that your requirements can change. Don't close doors in the future, but at the same time, don't deploy all the additional complexity if you don't need it. Right? There's an intermediate. There's like a middle path here someplace that we don't do very well at.
Yeah, really critical thinking. Think of first principles and see what you really need versus what, vendor of your choice is selling you.
And the problem is we all are old men, so we're used to thinking this way. We're old people.
Yeah. TikTok is not necessarily the best source of truth.
You get to a certain age and you start, telling your age in hexadecimal, and that works pretty well.
Yeah. So I don't know. So is that it for SR? I mean, do you have any other thoughts, Jeff Doyle? I don't want to.
No, I've learned. I've been kind of quiet through this whole thing because I'm learning more than I'm saying.
No, that's fine. Good. That's well. I want to make sure that you're not like.
Well, I'm representing the audience here, I guess.
Yeah, I think another interesting point, since we are on the topic, is whether you use UN versus UA. One of my favorite topics in data centers. So let's kind of talk about difference. UN means shift and route. UA means send out, no lookups, right? So theoretically, if you are building something in a leaf-spine aligned structure, do you really want routing at all? If you want to get from left to right and you use some kind of controller to figure out where to go, why route in between? Why make it an IP at all? Why don't make it look like an ATM switch, or lack of better comparison? So I think consideration between UN and UA is very interesting. At the end, UN, even though you use segment routing, there's still basic routing. You still need to go through routing engine on your silicon. You still need to figure out what your next hop is and then route. Why? You already know the link. Most importantly, UNs are global. UAs are local. So you can reuse them. You can reuse them across different data centers, different pods, and whatnot. So I think if you are designing such data center, give it serious consideration. The simplicity you could get with UA, which is really a bunch of cross connects. Again, think about frame relay. That's probably the best analogy here. You just switch together different VCs and you're done.
Isn't this partially going to be dependent on hardware, though?
There is no modern hardware that cannot do this.
Okay. I didn't know. I mean, I don't pay as much attention to the actual switching portion of a lot of hardware nowadays. It's kind of hard for me to keep up with everything. So I didn't know, like, if there was a big hardware war over microsids versus what's the other one? CSIDs for a long time. And so this is not the same kind of thing, though. Everybody does both.
There are some questions.
Yes,
yeah,
I know.
I was going to say I was kind of neglectful about the online questions coming up. Andy Whitaker is asking, kind of going back to SR, because I was slow here. But Andy is saying, what are your thoughts on SR with a controller in the data center? Do you like a controller in principle? Would you prefer a distributed source-based traffic steering mechanism instead?
So I'll give you my answer. My answer is, honestly, I prefer a controller for my policy overlay to throwing things in BGP. I've said this so many times that I think we put too much in BGP. And I get it. It works, blah, blah, blah. But honestly, you could build in a single data center fabric. If you really want to deploy SRv6, you could deploy a RabbitMQ database with a sidecar on the devices that drives the correct forwarding entries into the devices on all the boxes in the data center fabric. And I'm just saying RabbitMQ because a lot of people know what a RabbitMQ is. Some distributed database, I don't care what it is. And you just pull all that out of BGP.
I would like to emphasize the point here. You are not in a situation when in the one, each link is very expensive. They all have different capacity, and without traffic engineering, you really cannot make proper use of it.
Mhm.
You are in massively scaled out infrastructure. So take any modern switch, 51 tera, you've got 64 400 gig of links up if you do one-to-one over subscription. Do you really need to throw on top of it some traffic engineering or traffic steering besides basic ECMP? You know, it's 64 times 400 gig. It's 25 tera of capacity. And ECMP in most cases, again, we're not looking at something that is requires better load balancing, which in the AI case it is. Practically, you've got 25 tera of capacity to go up of any link. If this link disappears, usually modern hardware within 1 millisecond will remove it from the ECMP array. Your BGP will update everybody else within some time. But practically, you've got very well working machine. Any public cloud that is not AI works this way today. It's just basically ECMP, nothing more than that. So there is price associated with bringing controller. As we said, if you're bringing controller, probably you would like it to program path. On failure, you need to change the path because now it's program end-to-end, not just local decision in each switch. When again, on failure, within milliseconds, you just remove the stuff from your forwarding path, right? So you're spending significant amount of effort, CapEx and OpEx, and what you're getting in return. Probably something that's worse than before.
Yeah. So it also depends on what you're doing, right? So if I were building a data center fabric and I wanted to be able to do service chaining across it for whatever reason, pick your reason, or exit selection for whatever reason, I would prefer to do that with a controller than with BGP, right? That's just my general stance. If I have a policy problem that I want to solve, I want to separate the policy from the reachability.
I have a presentation from 2011 saying exactly that.
Yeah, exactly. Exactly. And so that's fine. So my preference is, if you don't need a controller, if you're just trying to get fast, then like Jeff says, be fast. You don't need a controller. Just let the thing do what it's going to do. It's going to work fast. If I need particular policies, then rather than trying to code those into BGP or IS to IS or whatever it is I'm using, it's a lot easier to let those protocols do their job, reachability, segmentation, blah, 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 and put the policy someplace else. It just feels so much simpler to me just to put the policy someplace else.
And also, don't forget, even so, we all love to think from network side. In a lot of cases, just plumbing. So the most of control is actually on the host, on the sender side. So congestion control, all kind of probing, it's all running from the sender. It doesn't care about the fabric in between this much, right? Congestion control is end-to-end, it's over the top. It will go all the way to the receiver, come back, and then sender will do something about it. And usually it's much faster than any routing protocol can do. So again, before you go and start over-engineering the fabric, look at what your sender is capable of. Usually it's 3 orders of magnitude more capable than what your network can do. Think from end-to-end perspective.
Yeah. I don't know if that answered your question, Andy, but that's kind of.
Yeah, so don't do it unless you really have to. That's kind of.
and if you do have to, constrain it to the point where it's solving a specific problem. Don't try to overgeneralize. That's always my kind of
And
thing.
again, I would recommend go and read the draft. It's called something backend, services backend. It talks about real deployment. It's really large scale. But think about what we discussed kind of before: complexity, feedback loop, and what you do with it. Because it's absolutely non-trivial and it is really complicated.
Yes. Yep.
I know this really good book on network complexity.
No.
What do you mean no?
One of the somewhere.
Somewhere.
Yeah, I can't remember why. I used to have my copy of it around somewhere so I could wave it around in the show, but I'm not sure where it is now.
Now we just have Jeff's
There
blurred
it is.
One of
chair.
those, somehow it doesn't. I'm not sure why. Oh,
There you
It's
go.
got to be closer to your face. It's doing face detection.
yes.
The beauty of AI or the horror of AI, depending on your perspective.
But yeah, I mean, that's still, you guys have sort of, I know you weren't intentionally plugging your book or anything, but you know, everything you've been saying about every decision has a cost, you know, and there's always trade-offs and all of that. That all goes to that book.
Yeah, it's funny. I work a lot with research people in kind of in NVIDIA and around, and they keep on asking questions that we really kind of addressed in the book. And every time, have you tried to read this book? They say, "Oh, I didn't know it exists." And then they read it and say, "Hey,
That's
there's
always such an easy answer, isn't it? Read my book.
So
Where
yeah,
are we? So yeah, I was just looking at the time here. Is time always kind of just
Man,
blows
time
right
really
by
flew
when it's the
by.
three of us. Do we want to try to wrap up here, or do we have a few points yet to make?
I think we are kind of close to wrapping up. I would really like to have Russ pretty soon with us again. We'll discuss a variety of different topics, and you know, it's so great to be with three of us here. It feels like so comfy, like I don't know,
Yeah.
your home, right?
It really is.
oh my goodness.
It's been way too long since we've had you on.
Yeah. So let's wrap up for now and kind of agree, Russ, you promise by doing so.
I
I heard him promise.
I'll be glad to
three
come
of
back
us, and there's a whole bunch of interesting topics we can think of.
Yeah. Yeah. And Russ, you know, anytime you just feel like, hey, I want to talk about this, you know, ping us. We'll stick you on the show in a heartbeat.
Okay.
Okay.
Great,
Well,
everyone.
I want to thank everybody in the audience for joining us, and I hope this was informative. It was certainly informative for me. As Russ, as always, I mean, we've kind of already said that, but it's so much fun having you on the show.
Well, thanks.
It's just, you know, I think,
and of course, you two know that you have an open invite to the hedge as well. Just so you know, just to point that out.
Yeah. Hey, well, you know, since you brought that up, plug the hedge.
There's nothing to plug. I mean, it's a podcast. We talk.
Where do you find it? Do you have a link?
You can always find it at rule11.tech. You can find it on Apple, and I don't know, it's all over the place. I don't really know. It's on Blueberry. So wherever Blueberry pushes stuff, that's where it ends up.
Okay.
So hopefully you stop bullying your co-host about the plants and
No. We need a plant cam for Tom's plant. We need pictures of the plant.
Cool. See you soon, everyone.
Thanks, guys.
Yeah,
and
okay.
great to see you.
Enjoyed it.
Great to see you. Yep.